this computer. Okay, so your worksheet looks like this, system of equations. The instruction says, find the solution, point of intersection, for each system of equation using a graph and table. Don't forget to circle the point of intersection. So I'm going to run through a couple examples. I'm not going to go through all of them just because when I was recording the video for each problem, it takes about like 7 minutes to actually explain everything. And if you do the math, that's like a 30-minute video. So I don't think you want to hear me talk for 30 minutes and you guys don't get practice. So I'm going to do a problem similar to number 2 and a problem similar to number 4. Okay, so I'm going to start with number 2. So I created an extra set of problems for myself that look like number 2. And you'll see that in the video if you watch it. I have 4 examples that look very similar to number 1, 2, 3, and 4. And it looks like I numbered 3 twice. Anyway, so we're going to start with the problem similar to number 2. And I'll write that problem on the whiteboard. So that problem is y equals 3x minus 4. That's our first equation. And our second equation is y equals negative 1/2 x plus 10. When we have these 2 equations, we want to see where do they intersect each other? Where do they cross paths? So I'm going to draw a sketch of a graph. And I'm going to take questions at the end of finishing this problem. So when we have this graph, we're going to graph the first one, y equals 3x minus 4. We know that minus 4 is the y-intercept. So this is the y-intercept. And 3 is the slope. And as a reminder, the slope is the change in y over the change in x. In this case, our slope is 3/1. And for our second equation, we have our y-intercept is positive 10. And our slope is negative 1/2. So our change in y over our change in x is, change in y is negative 1, because we say negative 1/2, not 1 over negative 2. So negative 1/2, and our change in x is 2. With that said, we're going to graph it first. So negative 4, we've got to start at negative 4. So 1, 2, 3, 4. And then I'm scanning by ones. 2, 3, 2, 3, 1, 2, 3. Okay, so I go up 3, 1, 2, 3, because that's my change in y. And then over to the right 1, because that's my change in x. Up 3, 1, 2, 3, oh, to the right 1. Up 3, 1, 2, 3, to the right 1. Then you'll have a graph that looks something like this. So our coordinate is 0, negative 4 for our y-intercept. And our slope triangle shows that our change in y is positive 3 and our change in x is positive 1. Now that we graphed our first equation, we're going to graph our second equation. And 10 is our y-intercept. So I think I have to go a lot higher. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on your homework, it should be a lot easier because I provided you a graph to graph your equations. So we start at 10, positive 10, 0, 10 is my y-intercept. And my change in y is negative 1, and my change in x is 2. So that means I go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. and so forth. So as I mentioned a little earlier, my graph is not going to be perfectly accurate because I'm drawing a sketch. And this point right here in black is what we call our point of intersection. And that point of intersection looks like, so I got 1, 2, 3, 4. And it's going 1, 2, 3, 4, 5, 6, 7, 8. So 4, 8. We're going to verify if that's a true point of intersection by doing tables now. So this is our graph. These are our graphs. Now we're going to make our tables for each one of these. Our table, I'm going to make one in red to show my first equation. And then one in blue to show my other equation. Okay, so with that said, I'm going to start the one in red equation. So my y-intercept's at 0, -4. And then my slope is 3 over 1. So my change in y is 3, my change in x is 1. So each time I am adding by 3 along the change in y. And for my change in x, I am going to be adding 1. So -4 plus 3 is -1, -1 plus 3 is +2, 0 plus 1, 1 plus 1 is 2, so forth. And I need to keep going to eventually get to 8. So 2 plus 3 is 5, 5 plus 3 is 8. And then add 1 each time along my change in x, 3, 4. Okay, so I have my table for my first graph. And if I want to go backwards, you just subtract 3 instead of adding 3. And subtract 1 instead of adding 1. So -4 minus 3 is -7. -7 minus 3 is -10. -1, -2. Now we graph our second equation. So start at 0, 10. My change in y is -1. So subtract 1 each time. So 10, 9, 8, 7. And then my change in x is +2. Add 2 each time. So 2, 4, 6. Then go backwards, add 1. And subtract 2 going backwards. Get 10, 11, 12, 0, -2, -4. So when we look at this graph, when we look at our tables, -2, -10, does it match with -2, 11? No. So they do not, they're not the same points, therefore they're not intersecting. -1, we don't have a -1 here. 0, 0, -4, 0, 10, that means they do not intersect. We don't have even numbers, odd numbers, so we can ignore 1, -1. 2, 2. Is there 2, 2 here? No, they don't match. 3, 5 is odd, we can ignore that. 4, 8, we have 4, 8 here, yes. So they both share the exact same points, which means that they intersect each other. We show that they're intersecting at 4, 8 on the graph, as well as the tables. So I'm going to take some hands. I think Angel raised his hand a few times. Go ahead and ask your question if you can unmute yourself.
So, how did you get, so the y is always the slope, right? Or
M is our slope. So y equals mx plus b. M is our slope. And b is our y-intercept.
Oh, so m is the slope, right?
Yes.
Okay. Wait, but why did you put 3 over 1 in the...
3 over 1 is the same thing as 3 divided by 1, which equals 3.
Okay.
If you just wrote 3, what are you changing along the x. We need to change something along the x. So you just write 3. We have a change in y of 3. But what are we changing in x? You have to have a number there. And 3 divided by 1 is the same thing as 3.
Okay.
Other questions?
No.
Okay.
Thank you.
For those who are joining us a little later, this is all pre-recorded, so you can watch the video later for the time that you missed out. I think that's it. Okay. So any other questions before I move on to the next example? Okay, so I'm going to take a photo of this as a record, and then now I'm going to clear the whiteboard and move on to our next example. How do I clear over here? Okay, so I did a problem very similar to number 2. Now I'm going to do a problem similar to number 4, where both equations are not written in slope-intercept form. So number 2, and you'll notice the same thing with number 1 and 3, they're written in slope-intercept form, y equals mx plus b. But for problem number 4, it's not in slope-intercept form, it's in standard form. For those who are joining in, the word of the week is solution. Word of the week is solution. So let me find my cursor. Make sure you write down your homework for the word of the week. Okay, so now, yes, that's for the new homework. Now I am going to do a problem similar to number 4. So I'm going to write this in black. The equations are 4x minus, sorry, it's plus 2y, 4x plus 2y equals to negative 10. And the other equation is going to be 6x minus y equals to negative 3. As a reminder, both of these equations are written in standard form. How do I type in the, sorry. So both of these equations are in standard form. And we need to change them to slope-intercept form. And to do that, we need to get y by itself. So to get y by itself, we will need to subtract 4x on both sides. So we are going to subtract 4x on the left side. And subtract 4x on the right side. So our new equation now is 2y equals to negative 4x minus 10. To get y by itself, so that it can be in slope-intercept form, which is y equals mx plus b, we divide by 2 on both sides. And our equation now is negative 4 over 2x. Negative 10 divided by 2 is negative 5. Negative 10 divided by 2 is negative 5. And then negative 4 divided by 2 is the same thing as negative 2. So y equals negative 2x minus 5 is in slope-intercept form. We're going to need that equation to graph it. The reason why we want to change standard form to slope-intercept form is that we cannot graph or make a table unless we have it in slope-intercept form. You can't make a graph out of this because you don't see the y-intercept, you don't see the slope. Now we're going on to the next one. So to get y by itself, we subtract 6x on both sides. And then we're left with negative y equals to negative 6x minus 3. And we want a positive y because we want in the form of y equals mx plus b. So we divide both sides by negative 1. And we get y equals to -6 over -1 x, and -1 over -3 is +3. This is the same thing, -6 over -1 as 6x plus 3. Any questions about how we convert standard form to slope-intercept form by rearranging the variables to get y equals mx plus b? Okay, I'm going to write these two equations in the upper right-hand corner because I need all this white space. So we have y equals -2. Let's rewrite that. Y equals -2x minus 5. And our other equation is y equals to 6x plus 3. I'm going to delete all the other parts. Okay, I think I'm going to write this in pen on my paper first because it's easier just to wipe the whiteboard than try to delete each of these little handwritings. So I'm going to clear the whiteboard and I'm going to write the equations again. So my blue equation was y equals 6x plus 3 in slope-intercept form. And my red equation was -2x minus 5. And originally it was written as 4x plus 2y equals -10. And the other standard form equation was 6x minus y equals to -3. Okay, so now we can get to the graph. So if we were to graph this, we know that our y-intercept is -5. So we start at -5. Let's label my graph first. So one color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So we are looking at y equals -2x minus 5. We have -5, 1, 2, 3, 4, 5. And then we have -2. So our y-intercept is 0, -5. And our slope is -2 over 1. So go down 2, 1, 2 over 1. Down 2 over 1. And then we can draw a line. Okay. And for our line, we have a change in y is -2, and our change in x is +1. So change in y over change in x is -2 over 1. For our other equation, we have 6x plus 3. So our y-intercept is 0, 3. We go up 6 over 1. So 1, 2, 3, 4, 5, 6 over 1. And then go down 6, 1, 2, 3, 4, 5, 6 over 1. So it should be right there. Then we connect our points. And it looks like it intersects. Don't let that person in. Okay, so now we are looking at our point of intersection, which is right here. So our point of intersection, it's a little hard to tell exactly where because let me try to, I wish there was a way to remove someone permanently besides the annoying. Okay, so the thing is my sketch is not completely accurate, and because it's not completely accurate, I'm going to use a table to help us out. So my change in y over change in x is 6 over 1. So So change in y is positive 6, change in x is positive 1. Change in y over change in x, 6 over 1. Now we're going to move on to the table. And with our table, we have our y-intercept is -5. So I'm going to start at 0, -5. And I know it's somewhere around the negative on the x-axis and negative on the y-axis. So I want to go backwards. And we know that the change in y is -2. So subtract 2 each time. And my change in x is adding 1. So subtract 2 is -7, subtract 2 is 9, -9, add 1, add 1. If I go backwards, I add 2 each time. Get -3, -1. And then subtract 1 by going backwards. So -1, -2. As a reminder, I know that point of intersection is somewhere around the negatives. So we're going to see on the other table. So 0, 3 is my y-intercept. And I need to add 6 for my change in y and add 1 for my change in x. So add 6 each time and add 1 each time. So 1, 2, 3, 9. 9 plus 6 is 15. Go backwards by subtracting 6 and go backwards by subtracting 1. So this is -1, -3, -3 minus 6 is -9, -2. And if you take a look at the table, which of these points match with each other? Well, the 2's don't match, the 1's don't match, the 0's don't match, the -1, -3 match, and the -2's don't match. So therefore, our point of intersection is -1, -3. And you can see that it looks like it's at -1, -3. So this is how you solve a system of equations. When you have 2 or more equations and trying to find where they meet up, where they intersect, you can do it graphically and you can do it through a table. Any questions?